All right, so let's go ahead and work through this problem. I've already written it on the board. If you can see on your computer screen, there's my marker. C3H8, which is propane, we're going to burn it, which means we're going to react it with oxygen. It's going to form CO2 and H2O. I've already gone ahead and balanced that, and you'll notice that it was 2, 10, 6, 8. So I just reduced that to a 1, a 5, a 3, and a 4. All right. So those are going to become important because we have to account, since this is energetics, we have to account for the amount of stuff that we're actually going to burn. Also, it is an intensive property. All right. Or extensive. Check that. Sometimes I get them backwards. So what we do first is we have to draw out. Well, we have to balance. Then we have to draw the Lewis structures. And then this equation is equal to the sum of bonds broken minus the sum of bonds formed. Okay? So if I look right here, I have to account for every single bond. And I didn't write it, but these are all H's. I guess I should write that real fast. All right, so I look over here. I have 1, 2, 3, 4, 5, 6, 7, 8 C to H bonds. Over here, I have none. So in every one of these, I'm going to have 8 CH bonds that I'm going to break. I also have 2 C to C bonds. All right? And then in reality, I would have to look up here. And since there's a 1, we're just going to leave it that way. But if it was a 2, I'd bracket all this and double all of that. All right, now I come over here. I still need to add to it oxygen. So it's just 1 O to O bond, but you'll notice this happens 5 times. Now this becomes kind of a clerical nightmare. You got to keep track of every single thing that you do here, so you make sure you do it right. All right, so those are the bonds broken. All of this, and I got a lot of brackets, but it doesn't matter, minus the sum of my bonds formed. So if you look now, I have 2 C to O double bonds. So I have 2 C O's, and that's really going to be times 3. Now you could just write 6 in the first place if you wanted to. Yeah, it's just about kneecap height, straight against that wall. All right, so we could make it, so I'm just writing it out. Then we come up here, in every water, we got 2 OH bonds. All right, but I'm going to have 4 waters. There should be some sheets just to chop up around that same spot.
Okay.
Is there not?
No, just this stuff.
And there's not more than that?
7, 8, and
Yeah.
Okay. I just wanted to make sure. When we dissolve it, I didn't know if it was
Okay. All right. I'm sure that was interesting for you as I talked to Mr. Goddard, who thinks he's going to dissolve acid and aluminum, which in reality he's going to react it. But whatever. That's just me being annoying. All right. Then what we would do is we would look in our table and find the values. I'm on page 316. So a CH bond is 413. A C to C bond is 348. An O to O double bond, where is it? It's just O2 in that lower table, and it's 495. Then I have my C to O double bond, that is 799. And then my OH, I end up with 463. All right, then you just have to do all of this giant math. You take this times 8, you take this times 2, you take this times 5, and you add that together. And I don't want to do that right now. Then you take this times 3, that times 4, and you add that together. And then you subtract. And that will tell you your total energy when we literally break the bonds in my propane and my oxygen to produce my carbon dioxide and water.